action. And one of the problems, not the only one, but one of them, is that many scientists assume that by giving information, data, facts in the most neutral way, people could just understand the implications and react and do something. But scientific information is the core of the message, but how we communicate this information is what really makes a difference. And there are two main aspects in communication that we have to take into account. First, I will always repeat this to anyone, is narratives. So it's really explaining your points as a story is the most effective way to catch the attention and engage with your audience. And this is about speaking, is about writing, and it's about visuals. And I use this example for the last year because it's a very good one. And Rita Thunberg is a clear example of a powerful narrative. And if you think about it, it was a 15-year-old girl that decided that she wanted to do something for climate change, and she decided to do school strike every Friday. And the idea behind is that no matter how small you are, you can do a step to do a change. And this is a personal or a human story behind that is extremely powerful. And we cannot forget, this is not just one time. I mean, this is happening always. If you have a good narrative, people open the ears and hear you. But besides this part of the narrative, you also need to take into account visual communication. And it also makes a difference because how a message is put visually can impact your memory. And a powerful image is an anchor in your memory. You remember that talk, you remember what happened. And here, my also favorite example are the climate stripes from Ed Hawkins, because we have seen thousands of charts showing global warming. But this chart is just simple and beautiful, and it conveys the message, and it has a narrative. It's visually, but it's also a narrative, to the point that people have been knitting scarves, they have been doing their COVID mask with the stripes, they have been painting walls in schools. So it's just powerful image that conveys a message, and that's the power of visualization. And it may seem I'm talking about in general, you know, how climate change is explained to broad audiences, but this importance of narratives and visualization is relevant for everyone. So it's relevant for policymakers, for industry, for civil protection, for agriculture. It doesn't matter. It is relevant to catch the attention and to get your message to all type of audiences. And what we do with this communication is we can either engage them, raise awareness, or trigger action. But when we talk about climate services, we really focus more on how to get information actionable. And in the world of digital media and digital transformation, this means that we will end up having a visual component that is going to be online, either in an app, in a screen, or something that people is going to be touching. So you need to get this information right. And this means that it is not just having one nice chart, is really getting to know that you need a lot of experts working in the service. So you need climate scientists for sure, but then you need a lot of different profiles. For sure, over the Living Lab, you have heard about the role of social sciences and many other aspects, but it's about everything. And I want to focus today in the role of design, of user experience, or the role of other profiles that they have been working for marketing and for data visualization in general, but that they are key also for climate services in this last part of getting a visual tool, putting this online and communicate it. That's the why, and what I wanted was to bring some glimpses of aspects that should be taken into account. And I put it the first because the last maybe people could forget, but I think is key, is design. And sometimes we have biases, but design is not something fancy. Design is something that is all around us. And we really only know that there is a design problem when it fails. And so design is more than just aesthetics, it's also about functionality. And it's also when you have an application that gives you very good information, but the back button is in the wrong place, you as a user, you get annoyed. So this is also design, and this is also a key part of a user being happy taking your climate service and using it every day, for example. But apart of originality, for sure, design has a factor of aesthetics, and we cannot discard it. And I will not repeat it enough times. Wow factor, having something beautiful, is also relevant because we have unconscious biases. We really like beautiful things. And this is an example of a scientific slide showing the impacts of dust on society. And this is exactly the same message, but with the intervention of a designer. It's not only more beautiful, there is a narrative, there's a story. There is a desert, there is a haboob, there is sources of dust, something that happens in the ecosystem, and a number of sectors and activities that get affected by dust. And this is not just very powerful to reach broad audiences. This really helps also scientists to convey their messages in a more clear way. This is a leaflet, but if I go to the actual example of a climate service, we have at BSc this seasonalhurricanepredictions.org, and it's open every summer for the seasonal hurricanes. And in this case, for example, at BSc we don't forecast hurricanes, and we don't forecast the number of active hurricanes expected for the season. But we created a service where we were aggregating the forecast from many institutions, and we were putting it together in a website that we wanted to be beautiful, impactful, just easy to access. And it's a success story because journalists love it. They come here, they have an overview, and then they go to the forecasters for more specific information. But it's an easy way to get an overview of the hurricane seasons. And at the end, we are only aggregating information, but the packaging of this information was really useful. And that's what it makes that it is a service that is keeping going on over the years, just because people like to use it. If we move away from design, but always related, there is a very important aspect, which is taking into account the color. When you're going to convey information in a climate service, you have to pay a lot of attention for color. If you're a climate scientist, you already know, you already pay attention, but there are aspects that sometimes we miss. One is the importance of building a service with colorblind friendly products. This is the typical color scale for precipitation, and this is a simulation on how people with daltonism can see it. And as you see, exceptionally above of average precipitation and much below looks almost the same. Okay, so this is something that affects 10% of male population. It's a problem that we know, and it's a problem that has an easy fix. So we should be taken into account when deciding something. It happens similarly when we create a risk map. We usually go and for the fire lights is what we are used. Culturally, we think green, red, yellow, or orange. But if you see a simulation of this risk map, okay, you can see the difference between the three colors. But what calls the attention here is yellow, which is the middle category, which is the non-important one, probably. So we have to take this into account and understand that normal practice doesn't mean good practice. And it's a responsibility for anyone working in climate services to gradually move out from normal practice that is not good for users and going to good practice. And I put here this extract from this hurricane service because you're going to hear a lot about some of our mistakes. Is that when we launched that service, we had to make the decision of colorblind friendly palette or not, and we end up with non-colorblind friendly. Then we got the complaints, and we realized that, okay, we put normal practice on the top, but that's a mistake. If you're working in climate services, users, the person reading the information, should be at the top of your priorities, more than whatever your colleagues or peer researchers or colleagues do. Also, this affects to very specific color scales that, okay, they are colorblind friendly, but they are not correct for a particular type of information. And you can read more about this End of the Rainbow and climate on Google. You have a link here to read. Rainbow color scale is beautiful. You have very impactful graphics and charts and a globe, but depending on what is the purpose of this visualization, we should move out from it. So we need to assess carefully And here, not to think about what is appealing visually, but what is really conveying the message that is actionable. In this case, you can read much more on this, but you see that kind of see a frontier. You see the red, yellow line, and then you have the rest. If you see this in a continuous gradient, you wouldn't be even able to point out where the yellow line. This is a problem of this color scale, among other things. So we have to be very careful and pay attention to this type of things. And finally, for color, remember, it's kind of obvious, but sometimes we forget about it. Colors also have meanings, and we have to be aware of it. So temperature is usually with reds, water, precipitation is usually in blue. If we paint a river, it should never be red. And then also, we can go one step further. If you are creating a service for Asia, colors might have different cultural implications, different to the ones of your own. And for this is why testing with users, making interviews, co-production of a service is key. Because when you talk with the users, then you learn. And then you learn about all these things. Then, okay, we have designed color, but then we get to actually put in a chart and making the service put into your screen. And here we have to make a lot of decisions about what it is technically called the visual encoding of information. And first, we have to decide which type of information are we showing and which is the right type of chart. If we have graphical, geographical information, maybe you have a map. If you have relationships, you might have a scatter plot, so you have different type of charts. Here also, to be practical, an example. This is a climate service that I was coordinating. It was a prototype for Copernicus climate change service for a prototype of service for journalists. And journalists might like maps. They might use time series, but there's something very specific for journalists, is that they always love to make rankings. They want to say that these and that regions were the hottest ones or the coldest ones. They want to say that this was the third hottest summer of the last 20 years. So we had to talk with them, learn about it, and then be sure that our service was providing the actual product they were looking for building their stories. This is an example. You know the type of chart. Let's imagine it's a map, but then you still have a lot of more things to decide for encoding. I put you this slide because I'm sure over the time, if you keep this slide, it's going to be useful for you. It tells you all the possible ways of encoding information, not only in a map, in a chart. Some are obvious, like color saturation, so more temperature, the more bright the red is, changes of different type of colors, differences in size, differences in the angle, for example, for wind, so winds blowing in the northeastern, north southwestern, or whatever. So there are many types of encoding. I'm not going to explain them. What is important here is that not all encoding is equally good. And here again, let's talk about some failures where we learned a lot. This is almost the first climate service with a visual component I was involved in. And it was a success in terms of media and in impact in the users, like, oh, wow, it's really beautiful. But once we were doing the actual testing with the users or the potential users for this tool, we find out that we were using the angle as an idea of having high probability of wind or low probability of wind going down. But because we were talking about wind, they were thinking about wind direction. And we had a very good data visualization expert, not from climate. And it's true that it's beautiful and appealing, but somehow it was really conveying the wrong message to the users. Besides this, we were using transparency. So the uncertainty in the data, the less good or the less confident we were in the model, the more transparent the data was. So you could see less the line. Which is the problem, is that in areas with very low skill, with low capacity of predicting, it was very difficult for the users to tell you the color. So at the end, it was beautiful. It was a very good proof of concept, but it was not practical because the visual encoding was the wrong one. Besides that, it's very important to highlight always that less is more. As scientists, and creating a figure, the more information you put, the better. But this is not the same for creating a climate service. Putting more information all together in the same place at the same time is good for the figure of a paper, but not for a service. And we have to be aware of this and try to avoid this mistake. But then you will tell me, okay, but I have a lot of information, so I need to put a lot of information. But there is where we have the interaction with the information, which is also key right now in the digital world with online platforms. We need to be able to put all that information, but to give it in a not dosified, no, but slowly. So there are two ways of doing this. One is providing a progressive disclosure of information. So it's giving information step by step, so the user goes deeper into more and more detail, and then allow, if possible, for an interactive design. And here I'm going to show you this in practice. So this is the project I was working in the last 3 years. You will be able to enter into that URL and browse it. But progressive disclosure of information first, that, okay, you enter here, this is temperature, and you see a color. And this is for last year, July last year. So you see a lot of orange here. Then you click, and then as a user, you get additional information. So you see that you had 96% probabilities of having temperatures above the average. You get information about the quality of the data and some additional information. Then once the user digests this, they can go further. They might have questions. Then they can go deeper, and you can get evolution over time, past performance over 30 years, etc. This is an example. I don't say it's the best one, but it's an example of progressive disclosure of information. Interactive design, it means that we could have this. This comes from the same tool, is a PDF. It's showing the forecast for winter of temperature. Everything is decided here. We decided to show a particular region. We decided to show extremes. Everything is done, which is quite different to get to here, say that you can decide the level of the quality that you want to be seen. You can be more strict. Then you could be deciding to show or not extremes, or change the level at which you see the information that is relevant. This is interactivity, and this empowers the user to see exactly what is relevant for them, and not what the scientist or the climate service developer thinks that is relevant for them. Another small aspect of interaction is something that no matter which climate service you are developing, we live in a world of apps, and we are used that when you hover over something, you get additional information about what is going to happen there. We are used to have tooltips where you can really get additional information, or you might be expected to have a guided tour. So you get to a climate service in an online platform, and you read about what is this about and how do I navigate over it. So, and then this takes me to the part that it was on the original title, is okay, we take all this into account, but then we get to the difficult part, which is about the visualization of uncertainty. And here, this is not easy. And it's not easy because it's a key challenge, not only for climate science, but for data visualization in general. How to express, present, and convey the message of uncertainty is something that is not solved yet. There's a lot of people in many fields working on it. So don't despair if it's difficult and you find that you don't see the right way of doing it. It's work in progress, and there's a lot of people working on this. What I would suggest I mean, it's maybe not the best publication, and you can find a lot of information, but if you want, there is this report in Climate Europe website, which was a summary of many climate services providers. They were together in a workshop, and they were explaining and having a joint discussion about which were the main challenges in creating visual tools. And there was a specific part where they were talking about how to communicate uncertainty. So it might be an interesting first place to read about it, but maybe later I can share more links with you. When we talk about uncertainty, there are many ways of thinking about it, but there are like mainly first, you could consider first order uncertainty, which is, okay, you have climate models, then they don't know exactly what is going to happen. They don't give you a deterministic value. They don't tell you next year the summer is going to be 28 degrees the first day. Usually we use models, therefore we have a number of answers, and then we have to convey these in probabilities. There are many ways of doing this. One, it could be just going for the easy way and saying, okay, I'm going to give you the number you want, so I'm going to give you a deterministic number, although I have a range. There are ways of showing this by using anomalies, by focusing in a particular threshold that is relevant for the user. So instead of telling you all the range of probabilities, I will tell you if there are high probabilities of having a very extreme and heat summer. There's the option of showing things on terciles, using the scenarios, mainly when we talk about projections, or providing the whole probability distribution. So as you see, there are many ways of doing it, and there's not a good one that works for everything. It depends on the user and the purpose and what you're trying to convey and what the other side needs. Besides this first order uncertainty, we have this second order uncertainty, which is the uncertainty related to the actual capacity of the model to predict what is going to happen in the future regarding climate change. Here again, we can see many different strategies, from projects that they are just trying to raise awareness in a particular sector, that they don't even show uncertainty. They need just to show a value to start conveying the message that climate change is going to drive a change in a particular sector, and you have to pay attention. And this example, for example, is about algae blooms in the Mediterranean. And the people in this project, they were telling, we first need to tell them this is going to be changing in the future. And then when you get the attention of policymakers, then we can start talking about the capacity and how much can we predict these blooms. We can show ensembles. You can decide to mask areas depending on the quality of the data. You can use transparency, although I would recommend not to use it, depending on what you're doing. And there are many other ways. So it's not easy. And I'm sorry I cannot get into detail into this, but it would require 1 hour or more. But I hope this gives you a first glimpse of how complex it is, but how beautiful this part of climate services can be. Thank you very much.
Thank you very much, Isadora. Thank you very much indeed. Thank you for your talk and expressing so many specific key elements in terms of a specific sector, like visualizing information in the climate service. Now, if there are questions among our attendees, this is the time for presenting them. So if you have question here, it is the right moment.
There is a hand raised by Tony.
Yes, please, Tony.
Good morning, Isadora. Thanks for that beautiful presentation. What advice do you have for normal scientists in terms of tools they can use to create more more appealing visuals to create better presentations that contain information in a way that's more accessible, more understandable for users. It seems like everything you showed seemed to have a lot of seem to require a lot of technical skills and tools that might not be accessible. Do you have any tips for, just your average scientist? Thanks.
I think one thing is to build networks. Sometimes designers, they are just looking for a nice challenge. So sometimes it's not about having money to pay a lot of things. It's just raising a challenge and then getting someone who is interested to give you some feedback. So sometimes it's cheaper than it might look. Not for a project that is paid, it wouldn't be fair to get for free, but it's something that at individual level you can do. Then there are practical things that improve a lot whatever you create scientifically. I mean, I started in science communication because I didn't want to do science and science figures in the way that my colleagues were doing. When I was doing my PhD, I refused that. So you can just read around. And basic things is like, for example, accepting that less is more, and trying, when you do something that is not for a paper, then accepting that it might be better to have 5 figures than one that has everything. That it might be better to have text, figure, text explaining the next figure, and text that just having a fancy figure with 7 layers of information. Because scientists can read it, but others not. Then on color, for example, you can go online and then you will find colorblind friendly palettes, Viridis palette, and it's very basic stuff. It's just not choosing that palette and choosing one that the scientific community is already using and that is safe. And these small things also help. And then also, if you don't have a designer, you have to package something beautiful, easy and fast. An easy and free tool is also, there is this Canva. I don't know if you have heard it. Just to make a nice brochure or a nice packaging of a report that doesn't look like a Word with a lot of information. It's for free if you are not using it for a big thing. And it can give you ideas of design, how much, where would you put information, it's a layout. And then in general, basic thing on design that we don't know as scientists is white space. It's important. So if you have the whole slide, don't fill it of information. Allow the people to have white space around your information, and then be sure that you focus exactly, that you make them focus exactly in what it is important. And it works for whatever figure you are doing in science.
Thanks.
Thank you very much. Thank you very much, Isadora. There is a hand raised by Victor. Victor, please.
Hi, good morning to everyone. Thank you, Isidora, for the beautiful presentation. It's just a short question, just to confirm, just to make sure if I understood properly. Is data visualization more important or critical for any specific phase from the data processing or analysis, or either interpreting result or communicating, or does apply throughout the whole process? Thank you.
I was really thinking on the stage where you start prototyping and drafting a service for the user. This is the part I have been focusing. You could be using data visualization for analysis, but for that, if you are focusing on the scientific part, you already do data visualization and data analysis. You know how to do it. It is really data visualization in terms of a user. It's with a purpose. And there, it really usually is another field, is really people that specialize in this, and they get a lot of money from the private sector for all the apps that we have in our smartphones.
Thank you.
Thank you very much again, Victor, for your question, and Isadora for your answer. Any other comments, questions, or something? if it's not the case, I will thank you again, Isadora, for being with us today, this morning. It was a really, really interesting and engaging presentation, as Luigi already wrote in the chat. So thank you again for being with us today, this morning. Thank you very much, Isadora.
Thank you very much. And you will have my presentation and my contact. So feel free to contact me or to drop me an email. Don't be shy. And I have no problem. If I'm busy, I will tell you, but take advantage of all the connections that this Living Lab is giving you and use them.
Thank you very much for your availability. Thank you. So we can move to the second part of the of this plenary. Actually, the second part of the first half of the of this plenary session. And again, Alessandro is the floor is yours for the next presentation about a very important topic that we address a lot in our really interesting project. So, Alessandro, the floor is yours.
And thank you very much, Massi. Can you hear me? Yes.
Yeah, everything is fine.
Okay, thank you.
Also the sharing.
And thank you. So yes, as a matter of fact, I think that this presentation is a sort of complementary with respect to what Isadora presented, because how here the main focus in how to communicate the value of seasonal forecast that or climate prediction in general that we can use in climate service, because there is a sort of conflict between the user perspective and provider's perspective with respect to the idea of the value of seasonal forecast or climate prediction in general, but more specifically on seasonal forecast, because we have two factions. We have the point of view of the provider of seasonal forecast, for instance, and for this part, this faction, the value of seasonal forecast is based on some kind of metrics of that, for instance, the ranked probability scale score, or something that like this, that could measure how close is the forecast to the observation in general. So it's a sort of global metric. While from the user perspective, this kind of metrics, so this kind of skill, maybe is not what they want, but they are more focused on something different, like the accuracy, the hit rate, the missing rate, because it's closer to the needs of the users, because they want to know how good is a forecast in predicting a specific kind of climate event and their impact. So these two perspectives and these 2 points of view is one of the main barrier that we have met in our project, but in general is one of the main barriers in the idea of climate service at large. So as I said, here we could talk about, just as example, about 4 different measures of reliability of seasonal forecast: the hit rate, missing rate, accuracy, and the metrics like RPSS. For this presentation, we'll use this kind of contingency table. We'll have to distinguish between event observed and forecasted, and events that are observed but not forecasted, and events that are not observed but forecasted. And these 4 main groups of events will be quite useful in the definition of accuracy, hit rate, and missing rate. So just to start from the beginning, the heat rate. The heat rate is, as you can expect, is the number of occurrence of certain event observed and forecasted with respect to the total event observed but not forecasted and the total number of the event. So this kind of rate here present. The complementary part is the missing rate, so is the measure of when the number of the ratio between the number of time in which a certain event is forecasted but not observed with respect to the number of time in which the event is not observed and not forecasted, and plus the number of event observed but not forecasted. Not observed but and not forecasted. Sorry. And the other another measure of skill is the accuracy. Why is a ratio between the number of time in which a certain event is forecasted and observed, and or not forecasted and not observed, with respect to the total number of events considered for the evaluation of the accuracy. So this is essentially, these three measure is essentially a ratio between a number of events observed and forecasted. While the metrics like the ranked probability skill score or similar, because there are several definition and formulas for this kind of score. In particular, we are talking about FAIR ranked probability skill score or something like this. So there are different formulas for this score. In particular, here, this is one of the more basic formula, while the P here is a set of forecasts with P between 0 and 1, and this represents the probability of each forecast, while the X is the corresponding observation coded with 1 if the event occurred or 0 if the event not occurred. And so this is just an example. This is the FAIR ranked probability skill score for the performance of the Durham width yield estimate based on the model Delphi. Is one of the models adopted in MetGold for the Durham width problem, but this is just an example. In this case, the model has fed with the SNWF seasonal forecast. And in this figure over Italy, the critical threshold for the ranked probability skill score is 0. So I don't know if you can see the color bar, but in general, the color turned to the red are generally greater than 0. So in this case, the seasonal forecast can provide an added value with respect to climatology. So this is just an example. We can use several kind of performance estimation. But this is not what the users want, at least in our experience, because in the user's perspective, a forecast is good or not if they could reproduce some kind of event relevant for certain decision, critically with a very critical impact in their business. So, for instance, when a certain climate index is higher than normal or lower than normal, or however, if there is a deviation from the normal values, from the climatology. And so this is the reason why they prefer something more closer to the idea of heat rate or accuracy. So in the next figure, we'll have a sort of collection of maps in the top left corner. We'll have the rank probability skill score, while in the right top is the accuracy of this model fed by the ACMWF forecast in reproducing deviation both low and high. So we are here reproducing just the accuracy of having deviation from the normal, the accuracy, the hit rate, and the missing rate for this kind of event. So for the deviation from normal, the skill score is always the same for sure, because it's a global index. It's not related to a specific event, and it is the same figure that we have already shown, while in this figure over there is the accuracy. So in the top left is the accuracy, and the color turned to the red are greater than 50%. In the bottom left, we'll have the hit rate. So when the model hit the deviation both low and high from normal, and finally the missing rate is the complementary to the hit rate. So if you this figure are more or less looks like similar, but there are something different, especially for the user perspective. Here we report just a scatter plot for the RPSS and accuracy, hit rate, and missing rate, and the linear dependency between the different measures is clear. But however, the contents, the scientific contents, is not so far. But however, is not the same kind of information. Because in these kind of metrics could, as also Isadora suggested, could play a role for filtering out some kind of data. For instance, here, an example from the MedGoal dashboard, when we have used as a filter the RPSS value below 0, and so where there are no a clear added value by using a seasonal forecast with respect to climatology, and so we'll just drop it out, mask out the value with the RPSS less than 0, but maybe the best filter a posteriori for the users is a filter based on the accuracy, for instance, because here we have reported an example of the accuracy for this specific case. In the top left, we have the fuel accuracy, while we have a sort of filter by using different threshold of accuracy. For instance, the accuracy greater than 50%, top right, 66%, bottom left, and greater than 70%, bottom right. So this could be another kind of filter, as Isadora said, and maybe it could be mostly dependent on the user needs and perspective, because these kind of tools should be useful and usable from the users. Indeed. So just to conclude, in the climate service, there is a very high demand on an operational definition of the reliability of climate prediction. And the metrics based on RPSS or some similar index not always correspond to the user expectation, because users are more interested in specific events that could have a high impact on their own business. And so the metrics like hit rate, accuracy, or missing rate could better fit these needs. And finally, focus on the deviation from the normal. We have understood that could slightly increase the accuracy of the of the climate prediction. And I hope that this short presentation could help us in distinguish between the different concept of reliability for climate prediction. And thank you so much.
Thank you very much, Alessandro. Thank you very much for this overview on a way to measure and also visualize uncertainty in terms of forecast, seasonal forecast information. If there are questions, please raise your hand and okay, we can be back for possible question at the end of the next contribution, which will be a small talk given by our Marta Bruno Soares from University of Leeds.
Yeah. Oh, hi. Yes.
Yeah.
Me. Yes.
Okay.
A very quick one. So, yeah. Sorry, Massi.
No. The floor is yours.
Okay.
Yeah.
Thank you.
Yes,
it's
please.
just a very brief presentation on continue a bit on this issue of evaluating climate services, whatever they are, and for whoever they're being developed and used by. And my presentation focused more on how we go about evaluating the benefits of the services to the end users. So it's kind of the end stream of the production, development, and use of climate services. So how do we go about understanding the usability and how beneficial the services that we are providing are to the end users? So that's basically the focus of my presentation today. I won't focus so much on what we're doing. Well, I will explain a bit what we're doing in MedGold, but it is an ongoing process at the moment. So there's not a lot of results I can present just yet. But I can give you a bit more of the conceptual, theoretical aspects around this issue of evaluation, and then I'll very briefly explain what we're doing in MedGold to assess the value of the climate services we're producing. So there's different names for it: evaluation, valuation without the E at the front, assessment of benefits. There's different names for it, but basically what I mean by this is really understand the value, whatever that is as well, because the word value carries also very different meanings. There is a tendency to attach the idea of value to economic values, but there's also, it is important to recognize that there might be non-economic benefits of the services we're providing. So when I talk about value, I talk about the whole range of potential benefits that can be yielded by the users when they use a particular type of climate service. Okay, so the valuation is about understanding what are the benefits of the information that we're providing, the climate information we're providing through a specific service to support particular decision-making processes. So how are users using it, and how are they yielding benefits from that use, and what kind of benefits are those to them? So it's all about the end users here. There are different reasons for pursuing these kind of evaluations. And I talk a bit more about those kind of reasons in one of my papers, but I've just included here some of the common ones. Obviously, at the top is normally kind of understanding how we can improve further services for the users. So in this case, the evaluation can be also linked to ongoing processes of feedback of how the services are being developed and how to continuously improve that service to them. But it can also be to understand the benefits that they can feel from using those services. So are they better prepared? Is it help to make them better decisions on their in the kind of activities and functions they do in their day-to-day? And the understanding the benefits and how, what kind of benefits can be brought to the users in terms of providing these services also links with justifying continuous investment in those services, keeping in mind that a lot of the services currently provided are, a lot of them come from National Med Services. National Med Services being publicly funded bodies, normally they need to account for their expenditure, and they need to justify why it is important to invest in a particular service or not. So these kind of evaluations can be helpful to justify those kind of commitments. Can also be helpful to justify when there are particular competitions for resources. So, should we invest in this service or in that service? Do we need a new service? So all of these evaluation studies can be used to justify that. And then also for a more kind of private sector perspective, putting a cost attached to a particular tailored bespoke service, and kind of as a way of justifying to their clients why they're charging for a particular price for providing them with that service, can also be, these kind of assessments can also help them to justify that costing. And then ultimately can obviously, in terms of, for example, adaptation approaches, there's normally different pathways towards adaptation to climate change, and understanding if these services are yielding the right benefits towards helping us prepare to adaptation can also be used to help us better understand where we should be investing. Just some broad points on evaluation, and again, this is quite an emerging area in climate services. It is, I think there is a wide recognition for the importance of these kind of studies. As I just said, there's a number of different reasons. There's different reasons for doing that. But ultimately, the way we do it, how we approach it will depend on a number of factors. So not only why we're doing it, but kind of expertise and resources and funding we have available to do these kind of evaluations. The stage at which the climate services is at is also important, because obviously if you already, for example, implemented a service, but you're still at the stage where you're trying to assess how it's being used, it can lead to a different type of evaluation against, for example, a climate service that has been running for years. So it's slightly different approach how you evaluate the service. There's also different types of benefits that can be yielded. As I said before, the tendency up to now has been pretty much focusing on economic value. So the economic benefits of using an information, for example, in a particular decision context. But it is important to recognize that there's also a range of different social environmental benefits that can be yielded, and perhaps those should also be equally recognized as well. So what I'm saying with this is perhaps less tangible benefits, but nonetheless represent a real value to the end users. And this is particularly relevant in least developing countries. So where we're talking about really vulnerable communities, for example, where perhaps there's not really, perhaps the provision of climate service and specific climate information might not yield necessarily an economic value, but might have an environmental value or social aspects on how they interact and how they react to that information. So it is important to recognize that there is a range of potential benefits. Within that, bringing in different methods to pursue the evaluation can be helpful to provide us this more holistic assessment. The reason why I say this is normally, and the next slide is a bit more about the methods. There are particular methods that are very much focusing on economic assessment. So if you decide to go for a specific method, it will provide you a particular type of evaluation, and therefore you might be excluding other potential benefits that might be equally important. So perhaps considering mixed methods kind of provide you a much more holistic understanding of the potential benefits of that service. The final point is about the type of service itself, the type of climate information you're providing. There are very different, the way we try and assess the benefits, either being it real benefits, so benefits that are already being, you're already able to capture in real time, as opposed to potential benefits. So because there's also that difference, depending on where we at with the service, we can either talk about the potential benefits, so the perceived benefits that the users think they might be able to generate by using that information, as opposed to I am already using the service and these are my real benefits. So that's the difference as well. And similarly, if we're talking about a service that provides, for example, seasonal forecasts, so in the next few months, it will be much easier to assess in terms of the real value, as opposed to climate information that will give you information for the next 50 years. So obviously, the kind of information that is provided with the service will also determine how we approach these evaluation aspects and the kind of outcomes we get from it as well. As I said, in terms of methods, and there's a few, I put it there, a few references that kind of pick up on some of these methods. If you want to know more about this, I just included here the key ones that people tend to talk about when we talk about evaluation of climate services. I'm not going into detail here. I'm just going to say that, as I said before, there's a whole range of different methods. Some are very, very quantitative. It's like economic decision modeling, econometrics, and all that. It's really much focused on the quantification of the economic value of using that climate information, as opposed to not using. And then on the other hand, you have the more participatory methods where it's much more exploratory, much more based on perceptions of users and how they see that value being generated. So there are pros and cons to all these methods. Actually, my paper talks a bit about that. So if you want to have a better understanding on when to apply the different methods in different situations, that might be a good starting point. But as I said, this is kind of an emerging area, so people are becoming more aware of this and really trying to think through about some of these implications in the work they do in climate services. So just a couple of slides then before I finish on what we're doing in MedGold. So as you know, we have different pilot climate services that we have developed over the years. And the way we decided to approach this in terms of how we go about understanding the value or potential value benefits of these services to the end users, we've decided to develop a common conceptual framework that we would use across the different pilot services. So this is the simple schematic of the conceptual framework. And as you see, it focuses on the aspects around usability of the service. So, I should say as well that these components, when we're then interacting with the end users to try and understand the added value of the services, each of these components have specific questions to ask about. So, for example, in terms of the usability of the service, we ask them about how relevant the service is to them, the particular information that is provided in terms of timescales, temporal resolution, variables, but also in terms of, and coming back to the point that Isa was saying earlier today, how they interact with the platform. Is it easy to access? Is it easy to understand the information, the colors, and all of that? And then we touch upon as well external factors that might influence their ability to use that common information. So it's not only about how easy and usable it is, the information that is being provided, but if also understanding the wider factors that might affect their ability to use that information. And then that leads us to the questions around, have you actually been using the information that is being provided through the pilot services? Would this be something you would use? And again, here was about some pilot services have been kind of the end users have been more engaged with the pilot service. In other cases, not so much. So we had to account as well for this differences across the different services. So in here we ask about either their real use of the information or potential use, as in an ideal world, if this was available to you, would you use it? And then all of this lead us to really try and understand, so if this was the case, what do you think would be the benefits you generate from this? Or what are the benefits you actually found from this? So again, it's this idea of potential use versus real use. because different pilot services are at different stages. So these were kind of the key areas we've been doing. And within MedGold, we implemented mainly participatory methods. The reason being that there was different end users to different tools, and a lot of the kind of the assessment has been very much exploratory. So in terms of potential use and how they would see this being beneficial to them in the future. And so across the different sectors, as you can see there, we have different services as well. So the one you're most aware of is the dashboard, where we have specifically information tailored for the grape and olive oil sector, and also the durum wheat is coming in as well. But there's also other platforms that were further developed, further improved through the project, including the Olivia platform for the olive oil and granaduro.net for the durum wheat. So we had to make sure as well that we apply that conceptual framework I was just talking about across all these different pilot services through different methods. So there was the conceptual framework allow us to have a kind of a consistency on how we approached evaluation and how the kind of questions we wanted to ask users. But at the same time, flexible enough to allow us to do it through different methods. Particularly, as you can imagine, with the pandemic, we had to adapt a lot of these things as well. But it was a mix of online surveys, online workshops. For the grape and wine, we did some slightly different. We basically requested participants to engage with the dashboard throughout a period of 6 weeks, where they would provide us feedback, online feedback every week through their interactions. We asked them to think about specific decisions they would have to make and reflect on that and when they're interacting with the dashboard. And we're now going through interviews with them. So I'm doing these as we speak. Well, not right now, of course, but I have one later today. So we've been kind of doing a mix of different methods, but always looking at similar questions in terms of the conceptual framework and what we want to understand. And literally what we want to understand is how usable is the tools now that we have been working on them over the years, and what is the benefit of those to them, either real benefit or potential benefit looking forward. So this is still ongoing. I don't have a lot of results just yet, but watch this space, as I say there, because we will be finalizing the report soon, and we're also planning a couple of papers on these. So we're hoping to have a bit more findings in the next coming months. And that's it for me. I mean, there's a lot more, but I just try to be succinct and provide you some just snippets of ideas of things to think about if you want to consider doing this. And there's some references there. Yeah, thank you.
Thank you very much, Marta, for your talk and for presenting us these very informative thought and glimpse of key points on that. Thank you very much again. Please, for the question to Marta, please, we can postpone the question for Marta since we have now to a brief comfort break, just a few minutes, and then we will be back for the presenting groups. And we know that Antonio has a limited amount of time for listening to us. So my intention is just to postpone a question for Marta after the presentation of the blue team after the comfort break. So for the comfort break, just 4 minutes, okay? It is 16 at 12:20 we will reconvene here, and the blue team will start the presentation. Okay, so see you in a few minutes.
Thanks, see you later.
Welcome back to everyone.
Hey, hello, everyone.
I'm here.
Hi.
Alessandro, would you like to introduce the blue team?
Yes, sure. The first team that present the work done or planned so far will be the blue team that cover the wine problem presented by Antonio. And without any other words, I would like to leave the floor to the team. I don't know if you are already choose a name for your team, blue team, or not, but in any case, the floor is yours. Let me know if you want to share your screen by yourself, or if you prefer that we'll share the screen in your behalf.
I think it's better if we share our screen. I can go.
Yeah,
Can I go?
We cannot see your screen so far. Okay, great.
Right.
Now it's
Just a second.
yes.
Good.
Yeah.
Hello. So let's start. We are choosing a name actually for our blue team, and the name is listed here. Sorry, my Portuguese is not to the challenge, but that's our name, and because I was told that it's like cheers in Portuguese, in the Portuguese language. And yeah, in this short presentation, we will present our roadmap and the work that we have done so far. Actually, first of all, let's see if I can. Okay. Our team is the member of our team are listed here. It's a very mixed team, many different backgrounds. From climate, but also social economic field and infectious disease and plant specialist. It was good to work together, and we saw that different backgrounds are very important in this kind of services, but also it's not always easy to understand each other when we come from different fields. So not only with dealing with user could be a challenge, but for sure even dealing with different background. The challenge that was proposed from Soares is here. So in short, how a farmer should pay for a services that can correctly forecast infection risk. To approach this problem, we thought that the first step should be the evaluation of the seasonal forecast. Here I write the evaluation of seasonal forecast heat rate, but as Alessandro just explained, heat rate can have different meaning, and from a scientific point of view, the verification of the forecast could be very different that what farmers are needed and or what farmers want to have. So in our case, we choose to evaluate heat rate as the number of time that the seasonal forecast was correct in comparison with observation. So, for example, seasonal forecast said that that season will be wetter than normal, and that season was better than normal. That is a hit. In the opposite case, we will have a miss. We choose to, as from the moment that the problem was about infectious disease, we choose from the dashboard some of the indexes that are available, and that is the spring rain and the SU35. So one is based on the precipitation, and one is the number of days with the high temperature. We evaluated the heat rate with some data that are available in that was just an exercise, so we didn't use all the time series that it is possible to have from the dashboard, but we just put some data to play around, and from this evaluation of seasonal forecast, we move to a cost and benefit analysis. I think that Christine will speak about in details about this cost benefit analysis, and she will for sure highlight the challenge that we face when we were together and thinking about what could be the cost for the farmer and what are the added value of having a seasonal forecast available for its field. Then the last part is an attempt to adopt an ecosystemic approach on the problem, because for sure climate is a very important variable in when we are making wine, but it's not just the climate that influence the yield, but also not just climate that influence farmers' decision. Maybe we have a different style of conducting a wine growing business. That maybe is based on experience, maybe is based on sensitive. So could be many other factors that influence the choices of a farmer in dealing with seasonal forecast or not using the seasonal forecast at all, because could be also that a choice. So yeah, that's I already spoke about this. So for user, the real question is how good a seasonal forecast could be. And of course, for science, the science can improve, can always improve, but it takes time. And the most important part that also in this lab I heard that we have highlighted very much is the transparency. So it's important to be very clear about what a seasonal forecast, what a forecast can do and what a forecast cannot do. For example, it's very common in weather forecast that people expecting hour by hour temperature or of amount of rain. And yeah, maybe it's better to be more clear that yes, we can give a forecast, but there are limitations and there are uncertainties. That does mean that the forecast is not useful, and that doesn't mean that the forecast is not a good forecast. We just have to say that there are limitations. There are also a lot of good potential. And here, this is the table of the heat rate that we compute. So we use the spring rain indices, SU35, and we also compute the GSP, that is the growing season precipitation. So meaning the sum of precipitation in the growing season, that is March to April. I have a lapsus on the month, but okay, it's the growing season for grapes. For sure, users are more up to date about this. And yeah, the seasonal forecast available on the dashboard can be initialized at different time. So we have computed a different heat rate according to the starting month of the seasonal forecast. For the growing season precipitation index, we start only in March because the season starts in March, so we use only that type of the forecast. That part is another it's on the on the to-do list. This was the part when we come together and try to understand really which could be the cost of our reduction from the farmer. And for this specific problem about downy mildew and sunburn and powdery mildew. That's a blank. It's a blank slide because well, we have put together our. I mean, if it was in real life situation, maybe in these slides there will be a photo of us thinking about the problem all together around a table, but we was online, so it was a discussion session to assess our point of view, our different point of view. And here I leave the floor to Christine that can explain the cost analysis benefit. I don't know if Christine preferred to share the screen by herself or if I can.
If you can keep it, that would be great, Laura. Can everybody hear me?
Sorry, I cannot hear you.
Yes, we can hear you.
Yeah, we can hear you.
Good.
Yes.
It's not so much a cost benefit analysis as I was just curious, and I made some Excel sheet table just to figure out how much a farmer is, how much a small farmer. We're going to focus on the 1 hectare farm, how much they're making or losing as a maximum, because I think that's the maximum your service can be. So these were the limits. So using the information that Antonio gave us, we can say that a 1 hectare farm has an average yield of 3,200 kilograms. And if they have the good quality wine grapes, then they would make 3,000 euros. And if you have a loss of 30% in the yield, you can lose almost 1,000 euros. And if you have sunburn loss or the powdery mildew, then you can lose around 600 euros. So this is the total loss that if they did no action, this is what your limit would be. If you can move to the next slide. So I only calculated at this point the downy mildew product.
Yeah.
Because we did this our work a little bit separately at the moment. We don't have a link yet as to linking the type of season to the number of sprays. But this, if you're going to protect from downy mildew, you have to buy the product. And in my head, I imagined I have 3 kinds of farmers. I have a reactive farmer who only buys things as they need it in the season when the costs are the most. I have a prepared farmer who says, I'm going to buy a little bit just in case there is sprays, which Antonio said that usually a farmer on the last few years has to spray for downy mildew between 1 and 5 cases. And then I said, okay, there's a really prepared farmer. And then there's this imaginary farmer that assumes that the hit rate is 100% of the seasonal forecast and he buys everything ahead of time, exactly as said. And I wanted to know how much they have to buy anyway, and what the total costs are. So if you had some prepared and you have a little bit that you have to buy again in the season, how much do you have and how much money are you now saving compared to this reactive farmer? And in the case where you have 1 hectare and you have to buy the product for 3 sprays in the whole season, you can save somewhere between either 130 euros or 190 something euros. And I did this for different numbers of sprays between 1 and 7. And I varied the number of prepared versus spontaneous things just to get a feeling of what this farmer's doing. If you move to the next slide, please. I also accounted for the fact that maybe this prepared farmer who bought 3 sprays, maybe he only needed 2. How much money is he going to lose at this time? Can you go back, Laura?
This is the slide or
To the slide with the number of 2 sprays. It's a second table.
sorry, it's because I'm going the wrong way. Okay.
Yeah. Yes. So if you had 100% hit rate, this proactive farmer compared to the reactive farmer, they're saving between 65 and 470 years if you had 7 sprays. But assuming that your hit rate is not 100% and some combination, I'm going to guess that the 1 hectare farmer saves between 150 to 200 or maybe 300 euros, depending on the knowledge, just for the downy mildew alone, if they had that. So then at this point, I'm just wondering, should I just imagine I'm still that farmer and saying, how much am I going to be willing to pay for the service? Like, I definitely don't want to pay 150 euros for a service that's going to save me 150 euros. I mean, these are things I can imagine, or you can tell me, and I can add that to our calculations. So this is where I stopped with the cost benefit, although there are other things to account for, whether or not you have to hire labor or the pruning of leaves or adding the mildew. But this is where I want to know what the difference between early hire, like how much are you saving by hiring early versus being a reactive farmer and hiring in the season. And one of the open questions I have is, if in the future we have a drier climate, will you actually, can you measure the benefit of not having a wet season or not? These are some things I was thinking about when doing the cost benefit analysis. And that's all I have for my part.
Yeah, that's the last part about this ecosystemic approach that is just a draft right now. We prefer to have more for today. We didn't have nothing ready for the ecosystemic approach, but we will try to have more details about this part. And but for today and for you, we have a list of questions that could help us to improve our job, our answer of the problem, and that are the questions listed here. So, yeah, what cost of grapes of quality wine versus average wine? So maybe there is a differences in prices and cost according to the variety. Yeah, the scale of the intervention, so small farmer, big farmer, middle farmer, I don't know. And yes, that's maybe it's the question that was posed in Christine. What is the relationship between a normal season, a wet season, and the number of spray that are needed? What is the cost and benefit of hiring labor here? These 2 last questions could be very helpful for the cost and benefit part. I think we can, we can summarize the presentation. Then we can hear from you. We want to hear from you about this question. In a few words, we assessed the seasonal forecast performance, and we ask ourselves how they can reduce the losses for farmers. We are aware that there could be a prepared farmer, a proactive farmer, and that's it's based on the factory point of view on how the people are dealing with in their sector. And from the side of the ecosystemic approach, of course, there are other factors as land use and land change policy that can influence the standard output, so the prices and the income that are not related at all to climate or climate change. And that's the systemic approach. I think that is all. I will leave the slide with the presentation. Sorry, I have too many. So I will leave this. So, and if Antonio or other user want to answer, for our side, it's all. That's our draft of our work.
Okay. Okay, thank you very much to Laura and Christine, but also to the whole group that has worked on this. I must say I'm quite happy with the way that you approached the problem. It seems to me you are on the right track to get to something. The scenarios that Christine has presented, the analysis of the scenarios do make sense with the limited data availability you have. That is about, for the case of downy mildew, what you can do. And it's quite interesting to see that when analyzing a 1 hectare only property in this situation, in this region, it becomes clear that maybe a price of a climate service may be something that is not worth the saving that it's bringing. Okay, so I would love that you develop this analysis for larger properties, and I believe Christine said that you already have. You are just not showing all the data because we don't have much time, and that's okay. But in the end, I will be very interested to see that, and I think that one of the questions of the problem, even if I haven't formulated it that way. And since you already did it for several sizes of property, is when at what size of property will the cost of a climate service be a good value proposal? So this is my initial comment. Now I would ask you to put back the slide with the questions because that is what I am here for, is to provide you answers to your questions.
If you prefer, Antonio, sorry to step in. If you prefer, we could send it to you directly the question, and maybe
I think I can address them in the 15 minutes I have available. And if then the group needs, I can interact with them by email. That won't be a problem. But they are not very difficult questions. So starting, what the cost of grapes of average wine versus quality wine? I don't think you need to deal with that, because the value I have given you is an average value for the wine produced in the region, provided for the grapes produced in the region, provided they do not have any disease, any physical problem, provided they are delivered in good condition. Okay. Of course, I could have supplied you with a number of other factors, like what is the downgrade on value if they are delivered crushed, or if they are delivered with a lot of leaves mixed together. We do have that type of penalties on the price we pay, but I think that would complicate the problem unnecessarily. So I think that the information I gave you of the downgrade from powdery, the declassification, the 20%, is about what you need to have, and the 98 cents per kilo of what I wrote to be good quality grape, actually what it means is grape without any quality problem. This is not the highest value we pay for the top quality grapes. We pay much higher than that. This is the average value for grapes without quality problems. So I think that would answer your first question. In the question of who intervenes, here I need a clarification. What do you mean in who intervenes? Do you mean who makes the decision of having or not having a climate service, or who makes the decision whether the grape has quality or does not have quality? What you mean?
Quality is related to the wine such as DOEC, EGP, and so on is the best wine. And the price maybe it's very different related to table grapes than DOCC wine. Okay.
Oh, okay. I see what you mean. Okay, no. Actually, we are the exercise. Sorry, are you listening to me?
It is a classic definition. I read the definition about the type of grapes is table grapes versus quality grapes and other grapes. This is the definition I read in different articles.
Okay, I see what you mean. But for this exercise, we are talking about appellation grapes only. In the Douro region, the quantity of grapes that are sold as without appellation is residual. It's really very, very small. I can easily say that about 95 to 97% of all grapes are sold with an appellation. And that's because in the region we have a coexistence of two appellations, which is Port for fortified wines and Douro for still wines. The value of 98 cents is an average of the average value for Port and the average value for Douro and fortified wines. Okay, so in terms of the cost of grape, the 98-cent value is already accounting for the vast majority, an average value for the vast majority of grapes being traded in there. But what I was asking is about the second question. The second question is who intervenes, and you ask only micro and small farmers. In this, the vast majority are small farmers. As I believe I told you in the beginning, in the Douro Valley, the average size of property is 0.9 hectares. And above 10 hectares, there are less than 5% of the properties in there. So the vast majority is small holders, small farmers, and in some cases micro farmers. So something in between 0.5 hectares and 5 hectares would comprise about 80% of all properties in the Douro. Now for the third question, you are asking what is the relationship between a wet season and the number of spraying treatments. I can tell you that this is something that has been changing because of climate change, of course. In the period between 1964 and 2017, the average per year were 4 sprayings. So the analysis that you have made is not too much off the reality. You used 3 treatments. I think that I told you this was the number from 1964, but if I take, for instance, from 2000 up to now, well, yes, it is still 4. So I think you can take the 4 as the average number of spray treatments on all types of years. On a wet season, on a wet season, which is really your question, and I'm going to take here the years like 2016, 2014, 2010, 2007, and 1998. That's it. So the average is 6. On wet seasons, the average is 6. The maximum we had, it was 2016, we had 10 spraying treatments. But that was, as far as I can see on the whole series, the highest ever. The second highest was 1971 with 8 treatments. So
Thank you.
that,
that was the question.
on that. Yeah. Okay. And regarding the cost benefit of hiring labor earlier, that is a very good question. And it is actually in the data I gave you, because the value there, 110 euros per hectare, is already the surplus cost. Okay?
That is the surplus cost.
Yes, it's the cost that you have to pay if you hire labor on the spot, if you were not planning for it. Because if you are planning for it, you can hire labor at a lower cost. But then, if you are surprised by a weather that a wetter weather that you were not expecting, then you have to hire more people. You can assume that this is the increase in the labor cost that you have to deal with. And I guess I covered your 4 questions. I still have 6 minutes left if you want to discuss something further or make any further question.
Could I step in?
Sure.
Because we are just a little bit long with respect also to the other teams. And I have some comments, but I'll put it directly in the presentation for the team. And one point that maybe we could assess together now is that, if I correctly remember, in the final session, you, Antonio, cannot attend. Is it correct?
No. Okay. Can you wait a second? Can you remind me the date again, please?
Next Thursday, so 24th.
No,
Thursday.
I'm not available on the 24th. We are not working on the 24th, and I am starting my holiday period then.
Mm-hmm. So could we send to you could the team send to you in advance the presentation?
Sure, absolutely. If you send, I don't know if you can do that, but ideally, I would like to receive it up to Friday, so I could have the weekend to look it over. But it may be too short for the
Friday
group.
Is tomorrow. Friday is tomorrow.
Oh, okay.
No, digo Friday.
Yeah, I know. That's what I mean. Ideally,
okay.
I would like to get it there so I could look it over the weekend. But I understand it's very short. So whenever you can, send it over, and I'll do my best to review it and reply back as soon as possible.
Do you think that someone else from Sogrape, for instance, Natasha, or someone else could attend the last session just to give some impression to the final work of the team, or it's national holiday in Portugal?
It's a local holiday here in Portugal.
Okay.
No one is working.
Okay.
And it's not just a local holiday. It's one of the most important holidays of the city here. St. John's.
Okay.
It's a big day.
Okay, great. So if you have, the idea could be that if you could send to us, to me, your question or your feedback on the work done by the team, I'll give the question for you to the team and go also to the final impression for the team. So if it's not a problem for you, we'll have some offline email exchange with the team and you. Okay.
That's not
Thank
a
you very
problem.
much, and thank you very much.
Even if I have to work later someday, I'm going in holidays, then I can rest. Don't worry about that. And
Okay,
good job. I'm really excited by what I saw today. Good job, Blue Team.
Thank you. Thank you.
I have to go now. Take care. Bye bye. Thank you.
Thank you.
I stop the shade.
Yes, thank you. And we are just a little bit late as usual, during the living lab, but it's a very common state. And so I think that we can quickly move to the second group. I think that the second group will be the Durum with team. Massi, I'm correct?
Yes, but Marta asked for a change
okay.
because
great.
Marta?
Sorry, my internet is not great. Yeah, I have a meeting coming up, so I'm wondering if the red team can go first, just so I can attend their presentation.
Sure.
Thanks.
Okay, thank you. Okay.
If they're ready, I mean, they might not be ready. I don't know.
So we can move to the red team quickly to present the work done so far on the olive oil sector. Please, if you could be just a little bit quicker than the first group, because they take just...
Sure.
They were just...
Can you hear me?
Yeah.
Okay, I'll try to share my screen. Can you see my screen?
Yes.
Yes, we can.
Okay,
yes,
perfect. And now it's on full screen, right? You can see the presentation screen. I'm just not sure. It doesn't show you. Okay, perfect. So from the red team, our assignment was the olive sector. And these are the team members here below. So the problem that Javier said was to understand how climate change will affect olive oil production in the future in Andalusia, but also in Spain, Europe, and the world. There are some suitable conditions for the growth of the olive trees in terms of temperature and precipitation that he gave us information on. And we decided to address the questions, will current olive tree producer areas stop producing olive oil? And will new areas become olive oil producers? So our proposal is to either create an indicator or a tool that shows the risk for olive production. So to combine climate projections of temperature and precipitation with optimal growth conditions for olive trees, and to also expand the area to cover further than Andalusia, to give the opportunity to DECOP and farmers to see their options about the future. So, for example, to cover the whole of Spain or the entire Mediterranean region. And our idea is, rather than designing the service, given the limited time that we have, to prepare the idea behind the service, so the steps to design this climate service, and present some background research on what is out there and what we could do. So the first step to design this climate service that we're proposing is to do some research and to see what studies say how will climate change affect the growth of olive trees. Will the production move in the future to other areas? For example, some research says that the UK will become a producer, or olive trees will grow in more northern regions where they weren't growing until now.
Then the next step would be to engage with the user and understand their needs better. This would be with some interviews, a workshop, or a survey. And we will discuss the steps in more detail in our final presentation, but now we're just giving some idea of how we thought we'd go about this. Then we'll have the actual research that we will do in climate projections, and this will be at the same time going back to understanding what DCOP needs and if what we're developing makes sense for them. And I hand over to Tony to explain a bit more about the research that we had in mind. Tony?
Sorry, I was muted.
Okay, sure. I'll go back to full screen.
Sorry about that.
There we go.
Okay, we had a number of services in mind, assuming that we had a different amount of time, depending on how much time we would have to develop a forecast tool or a projection tool. We had a number of services in mind, and we would coordinate with DCOP to see what their opinions are and what they would prefer us to do. So the first one would be to search for suitable areas or to estimate suitable areas for future olive oil production based on current and future temperature and precipitation thresholds. So with the dashboard, the MetGold dashboard provides us with a baseline for 1971 to 2000 to see, at least for Andalusia, what the climate conditions are, and Javier gave us numbers for the last 20 years in terms of olive oil production in Spain, and we could use those to estimate, in the future, other areas would be able to produce olive oil based on this climate envelope of temperature and rainfall. He gave us, winter precipitation is important. Spring temperatures shouldn't rise above a certain temperature. No frost during the summer. So we would use those boundaries to determine what other areas around the Mediterranean would become suitable for growing olive oil. A second step would be to include other factors in those areas in addition to climate. For example, soil composition, soil moisture, slope, solar radiation, which all determine how much solar radiation, how well certain areas can grow olives. But it would require more research and more time to find those numbers and create thresholds. So it would mean doing additional research. A third step would be to look into areas producing olive oil or are just starting to produce olive oil outside of the Mediterranean, but that could become suitable in the future because of warming, because of changes in the seasonality of rainfall. That in the UK, there's starting olive oil or olive production. So that would be our third step. But again, it would require more research because we would have to extend the area that we would look at and create thresholds. See if those other areas have competing interests from different crops, just different kind of land use. And could you go to the next slide? Yeah, and in addition, I think I just mentioned that, in addition to looking at just the climate envelope to see where olive production could go in the future, use the past production in Andalusia and Italy, Greece, Turkey, Tunisia, to estimate or to create a model that could predict future olive oil production based on the future climate, based on year-to-year variability, by combining past olive oil production and past climate, and then use climate projections from the dashboard for RCP 4.5 and 8.5, so moderate and high warming, to estimate future olive production, both in areas that could see increased but also decreased production based on climate change. Okay, and I'm going to hand it back to you, Andrea. Thanks.
Great, thank you, Tony. So back to the steps for designing this service. After this initial research, we will create the first version of the tool or indicator, and then do some testing with the user to get feedback, and then continue to further research and refine the tool to provide an improved version, and again continue with more testing and feedback into this loop over here. So we have two options that we would like to suggest to Javier. So option one would be something like a new risk indicator for the Met Gold dashboard. Since the dashboard is already there and is used by DCOP, we can create a risk indicator to add to the long-term projections that shows the risk of unsuitable growth conditions for olive trees. And it would combine projected temperature and precipitation with the optimal growth conditions for the trees to show these risks for the intermediate and high greenhouse gas emissions. So the second option is to actually create a new tool that focuses on olive oil production. The Met Gold dashboard already provides a lot of variables that are useful for olive oil, but this new tool could include other variables such as soil moisture, solar radiation, relative humidity, wind, and anything else that the user thinks is relevant to assess the production of olive oil. This will also show the risk again. It would have an indicator where it shows the unsuitable growth conditions, and we can basically build a new model that will be based on the relationship between olive production and climate parameters. So our questions to Javier would be which option would be more useful for DCOP. The option one, which is adding a risk indicator to the dashboard, or option two, which is a new tool separate from the dashboard that would focus only on olive oil production. And our next question would be more on how they're planning to use this information that we would provide, what kind of decisions you would base this information on, are you going to use it in the long-term strategy, or is it relevant for day-to-day operations? And who, where, and when are these decisions going to be made? And what kind of format would you prefer? Is it a report that you would need once a year, for example, or would you need it on demand? And that's it from me. Okay. I think I stopped sharing. Sorry?
Please go ahead.
I think I stopped sharing, right? Just to make sure. Yeah.
Is there any feedback from Javier? What do you think about this roadmap?
Okay, this is Javier. Can you hear me well?
Yeah.
Okay. First, thank you very much. Congratulations for your work, because you have been able to address the challenge to a specific issue. You have been able to synthesize all the information that we provided from the olive sector regarding the olive production, and that is a job that sometimes is not easy to do, and it seems that you have managed to do it regarding the question. Well, I need some time to think more about this question, but for the first question regarding the ocean, at this moment, I believe the ocean shoe will be more useful. And why I suppose it? Well, because during the medical workshop, because during the medical project, we have several meeting, workshop, or focus group with people, with the COP people. These people didn't suggest any. Can you go back to the ocean one, because I want to see the indicator, or
yes, so option one was the suggestion to have a new risk indicator for the Met goal dashboard. That would be in long-term projections, and it would be for the olive production.
Yes, but that is for the COP workers who attending the workshop of NetGoal, and these people didn't suggest a risk indicator or a optimal growth condition. Combining the temperature and precipitation. They suggest another other type of indicator, and for this reason, I believe that the ocean shoe is most useful, because the expertise people in the COP didn't suggest. I mean, they suggested many indicators. Some of these indicators is in the dashboard, and another not. But I don't remember now indicators similar as you propose. So in this moment, if I have to choose the ocean now, I choose the second. And
okay, great, thank you.
You're welcome. And the next question, can you show in? Thank you. I lost the. Okay. Well, it's similar to. I think I know now. It's similar to the question you have sent in a mail in this morning. Regarding the first, what decision will be based on this info? I believe in the long-term prediction about the estimation of the olive oil production, it affects to the commercialization issues. Or two, to the strategy movements or strategic decision. For instance, as I wrote in this morning, if you know, for instance, the future Andalusia wouldn't be a suitable area for the olive oil production. Maybe the COP needs to think in associate with other first degree cooperative in the north of Spain, for example. In the other hand, if the I don't know if the olive oil production in Andalusia increase in the next year because the photosynthesis of the olive tree increase. Maybe we or the call need to looking for a new commercialization strategy or agreement with another country. For instance, the call in this moment have a agreement with a company in United States in order to commercialize more olive oil in this country, to commercialize or sell all the olive that the crop produce or the first degree the crop produce. I believe, or as I see it, the decision will be more in this way, strategy commercialization, than in the agronomic or agriculture practice. The second, who, where, and when. Well, in this moment, I am thinking about the olive oil logistics department from the COP. And when, in this moment, I don't answer this question, but well, you can send me this question, because I am not the expert people in the call about the commercialization. I am not this type of people, but I can talk with these people. And the first, what for my second? Well, if we thinking in a long term, maybe in one per year or two per year, because I understand the long term prediction don't update all day. But I don't know. I am not the expert in this climate or in projection, in climate projection. But as I understand it, you can give all the day or all the week a new report or information or update the information for one thing you predict in a long term, in 10 years, go ahead and this. Formal, well, I thinking report like PDF or in a spreadsheet like Excel, because in my opinion, in the code, the people want to play with the with the number, with the results.
Okay.
For me, at this moment, that's all.
No, thank you very much, Javier. Sorry to step in and interrupt you. Maybe if the red team could exchange some mail, some other feedback with you in the next day, maybe it could be easier, because now time is running out and we have to move quickly to the final case because Matteo has other meeting in the afternoon and we are just a little bit late. So I would suggest to the team to communicate, if Javier agree, with Javier directly by email in the next days. Okay, thank you, Javier.
That's great. Thank you very much.
Thank you. So I think that we can very quickly move to the final group, the Durum Wheat group. Massi and Alessandro Triacca could report on the work done by you. The floor is yours. Thank you.
Good morning, everybody. Can you hear me?
Yes, yes.
Alessandro, can I ask you to give me the right to share the screen?
You should.
Yeah. Okay.
Okay.
Okay. Good morning, everybody. We are in the MedGoal Living Lab 2021, of course. The name of my mini project is optimizing the use of nitrogen fertilizer in durum wheat fields, combining crop models and seasonal forecast. At the bottom, you can see an image of durum wheat fields in Lebanon. What is the problem, as I understood from Matteo's presentation of 2 weeks ago? There is a critical need to advise in advance farmers and stakeholders on about how much fertilizer and when to apply it on the fields. These problems could be subset into 3 different groups. The first one implies climatic conditions. In the framework of climate change and higher frequency of extreme events and climate variability, adverse meteorological conditions like drought and waterlogging can influence the amount and the timing of fertilization for farmers. Related to this problem is the crop necessity, the crop nitrogen demand during its phenological stages. The lack of nutrients could require a higher nitrogen fertilization. And afterwards, the last sphere is related to the economic spheres, meaning that farmers need to buy fertilizers at the beginning of the growing season, so that the cost can be reduced. And in particular, there are problems related to fertilizer waste and overuse to reach the expected yield. What I propose is the combination of crop model and seasonal forecast. The crop model I would like to use is called the Model for Nitrogen and Carbon in Agroecosystems, also named MONICA. It was developed in 2013 by the Leibniz Center for Agricultural Research in Nuremberg, Germany, and it is a mechanistic process-based model, dynamic with a daytime temporal scale, and one-dimensional because it simulates a 1 meter square surface of 2 meter depth layer. This is Monica is able to calculate all the process that interact with the biochemical turnover of carbon and nitrogen and their transport into water in the soil, plant, and air system. There are 4 input modules that I need to feed into the model. The first one, of course, is composed by the weather data. I will talk about this in the next slide. The second one are soil and site data. What do I mean with soil and site data? Soil data required are the soil texture class, meaning the amount of silt, clay, and sand in the soil. Soil bulk or raw density, and soil initial carbon and organic carbon or the other organic matter, soil organic matter, initial soil organic matter. Site data instead are related to the latitude of the site we are simulating, the altitude, the atmospheric CO2 concentration, etc. Crop data are also very important. There are 50 crop data, 50 specific species-specific crop data. Like, for example, if the crop is annual or perennial, the organ names, the development stages. And there are 30 variety-specific crop data, like specific area index, specific leaf area, thermal time for development, and so on. Lastly, we need management data to feed into the model, like, for example, sowing and harvesting, for sure, of a given crop. And we can also simulate irrigation, fertilization, either mineral fertilization or organic fertilization, and tillage, for example. All of the management can be either specified, can be either applied on a specific date, or can be triggered by specific thresholds. Monica then is able to calculate throughout differential equations, soil plant system processes, and the transport of energy and matter in the hydro and atmospheres. What Monica can output are the variable I am listing on the right, on the top of the bottom right side of the page. For example, crop-related variables like yield and biomass, divided by organs or not, nitrogen and carbon, soil or crop content, soil moisture, leaf area index, all easy measurable variables. But Monica can also output non-easy measurable variables like N mineralization or greenhouse gas emission, nitrogen leaching, and multiple stresses like drought, oxygen, and nitrogen and heat-related stresses. Monica was implemented in C++, and it has a easy user interface written in JavaScript. It's open source and available on GitHub. What about weather data? I'm using seasonal forecast downloaded by the Copernicus Climate Change Service, of course. In particular, I'm using daily and sub-daily data on single levels, hindcast and forecast. Multi-ensemble, since there are 51 ensemble for hindcast and forecast. These data have a 1 degree times 1 degree spatial resolution. Therefore, I'm focusing on the on this square highlighted on the with red lines on the left, specifically simulating the Horta experimental fields close to Ravenna. I downloaded the data as a .grib file. Then I converted it into a .nc file and arranging the the values on each vertex of the red square, I'm obtaining .csv file that I need to feed into the Monica model, into Monica. Climate-related variables, you can see, for example, a typical climate file on the right that I can use for Monica. And for sure, I need average temperature, minimum temperature, maximum temperature, wind speed, global radiation, global net surface radiation, precipitation, and relative humidity. So what are my expected results? My expected results, comparing multiple scenario simulation of the Durham-Wheat field with Monica, I would like first to detect and highlight the most probable nitrogen stress periods during the development of the Durham-Wheat crop. Once I will highlight these and detect these stress periods, nitrogen-related stress periods, I can determine the best time window, fertilization time windows, that is time intervals where fertilization is maximizing yield and crop quality. Afterwards, I will try to reduce the amount of fertilizer to need to obtain the expected yield decided by the farmer. In particular, I would like to reduce the trade-off between amount of fertilizer applied to the field and the expected yield. As a final result, I would like to study the effect of different nitrogen fertilizers, since I can apply in the model, in Monica model, I can choose which nitrogen fertilizer to apply among urea, ammonium nitrate, and so on. Also organic fertilizers, of course. And finally, I would like to assess also the effect of the previously crop rotations, of different crop rotations on the Durham-Wheat nitrogen demand. Yes, this is all. Thank you.
Thank you very much, Alessandro. Thank you.
Okay, thank you, Alessandro. Do you have any question about your project? You have already sent me by email a few questions, but if you have other questions, I'm here. And for the time being, it's a very great job. You are taking into account all weak points, and I'm confident that you are building a big and a real good project. So I like your work because you are studying the project with a concrete work, not only theoretical or something like that. And I think you are working the right path, the right direction. Yes. Questions?
Not for now. Of course, after you gave me the soil data and now that I downloaded the climate data and I elaborated them, I can start with simulations from this afternoon, and of course I will email you about results and everything related to it.
And Valentina, my colleague Valentina, what do you think about the work of Alessandro?
I think it's a very interesting work. You performed a good research and found what seems a model really complete and really fitting the target. I mean, it considers a lot of inputs and seems to provide a lot of output that are really important for the problem we gave you. And I see you have a very clear way to work, and it seems really good to me.
Yes, you are using the approach of DSS. For example,
Yes.
the business of Horta is the implementation of DSS. First of all, you have to build a new model, forecasting model, mechanicistic model for DSS. You have to take into account all inputs, all variables, or yes, inputs that affects the outputs. And you have started in this direction.
Okay. No, I actually have one question, maybe. Like, for example, do you have data that I could use to validate the model? Since this model was validated for temperate and tropical conditions.
Yes, of course.
But of course, if you have like yields or something else, nitrogen content in grain nitrogen content, I can validate the model.
Yes, yes, we have a lot of data, leaching, yield, quality of kernels, and yes, because we collect straw and we calculate nitrogen content in kernels, in straw. So we study in north of Ravenna the nitrogen cycle. So we have a lot of data that we can share with you.
Okay.
To validate and also to build the model, to build your proposal.
Thank you. Thank you very much.
You have just to ask. Okay.
Okay. Thank you very much.
Good.
Matteo, Valentina.
You are welcome, Massimiliano, Alessandro.
Okay, so we end up this sprint meetings, the first feedback from teams to the problem holders. I saw lots of very, very interesting things. We don't have so much time probably to explore all the possible roadmaps that today was drawn by the groups, but I have the clear feeling that from your side, from the team side, you touched very well the complexity, but also the fascinating power of dealing with climate services, and this is something that is coming up from the presentation. So since we are really late as scheduled time, I leave the floor to Alessandro for the last contribution. For the last words.
Yes, no, last words, absolutely. Very few words. I think that all the teams have are in the right path, and also, more importantly, they have an open channel with the problem holders. So please take advantage of this channel of communication, and the next days, please interact with them. We'll reconvene to refine and retuning the final aspect of the exercise next Monday. We'll reconvene in the plenary, and then we'll split in the teams for the final work of each team. And thank you very much. We'll update the web repository soon, here in this afternoon, including the video of this presentation, of all the presentation of today. And thank you very much, and we'll meet again on next Monday. Thank you very much. Have a good lunchtime.
Thanks.
Bye-bye.
Thank you.
Bye-bye.
Bye-bye.
Thank you, everyone.
Bye-bye.
Thank you. Bye.
Everyone.
And thank you very much to our problem holders. Thanks again.